I'm Jeff Mawson, Application Engineer here at Advantech. Today I would like to introduce the new semi-rugged mobile tablet PC PWS-770, now available on our eStore. One of the key features of the PWS-770 is its advanced wireless capabilities. Let's take a look at how we design and test this system.
The procedure of designing a qualified antenna is quite complex and takes lots of effort. In order to present a clearer picture, the process has been simplified into 4 stages for this presentation. The first stage is antenna design and prototyping. We make a miniature antenna simulation using HFSS, an antenna simulation tool, to see if it will resonate on the desired frequencies. Then, we draw up a DXF sketch and use a PCB prototype machine to engrave the antenna. Once the antenna is made, we incorporate it into the unit and verify the return loss with the network analyzer. When it meets our criteria, we can move on to the second stage. Although the antenna is functional after passing the first stage, it doesn't mean that the RF performance is good enough. Thus, the second stage is about RF signal analysis and system noise debugging. There might be a lot of noise from the circuits and functions which coexist in close proximity to one another. If problems are not discovered and solutions found, the sensitivity of each function, like WWAN, Wi-Fi, or GPS, will be degraded. That's why we use a near-field probe and spectrum to help us achieve our goal. At the same time, there is a lot of environmental noise, for example, the Wi-Fi AP signal or the 2G, 3G signals from the base stations. So, we also need to run a debugging process in a shielded room to isolate environmental noises to help determine the precise root cause of the noises. After a series of antenna fine-tuning and system debugging processes, we are finally able to move to the third stage, the RF performance verification stage. With regard to Wi-Fi performance, users will directly be impacted by slow data rate problems and short coverage range issues. To prevent these problems, we test data rates with the Cisco Access Point and Throughput Test tool. At the same time, we can use attenuators to approach the limit of coverage range to see how far we can go and still keep connection between the unit and the AP. In the last stage, we test 3G quality and performance. As well as individual RF functions, the circuits and the active components influence the receive quality a lot. By using a shielding box and base station simulator, we can verify the performance of WWAN. Finally, the unit will be sent to a 3D chamber for TRP-TIS testing and results. These tests reveal 3G properties of the units in detail. After undergoing a challenging design and test procedure, let's take a look at how the PWS-770 performed. Wi-Fi is able to cover 106 meters both in the lab and in outdoor field trials. Wi-Fi passes our quality checks. For GPS, we check whether speed of the time to first fix is or is not fast enough, the biggest concern of users. A GPS simulator can provide an adjustable satellite signal, unaffected by weather, angle, and so on. With this instrument's help, we can get a precise test result. It shows that PWS-770 can get a first fix in around 40 seconds average, meeting GPS industry standards. For WWAN, PWS-770 has passed AT&T's over-the-air pre-test criteria, which ensures its performance surpasses the standard. PWS-770 has proven itself with stronger wireless performance. I'm confident and I'm sure you'll want to experience it now.